So today in our notebooks, we're adding justifying our steps in solving, and that is going to be on page 17. So you can pause if you need to add that into your notebook. Okay, and then when we're looking at our notebook, it's just one page, so we're putting that over here on the right-hand side. So today, basically, what we're doing is we're talking about the more important piece. Yes, it's important that we can solve an equation, but can we communicate that information? Can we justify our reasoning as to why we're doing it and not just saying, because my teacher told me to do it? Okay, and those are sort of the pieces that we want to look at today. So still that same concept of solving an equation, but now as we're taking those steps that we learned about previously, we then want to add that on with an explanation or a justification as to why we do it. So if we look at our first equation here, we have 8x plus 1 equals 20. Okay, and according to our rules yesterday, we know that we want to move this 1 first, and we said our inverse operation of addition was subtraction, and so we'd be subtracting 1 from each side. Now, you all sort of had the benefit because as I'm sort of going through and explaining that step, that's exactly our explanation and our justification, right? We know that these 1s are then going to cancel out, and so we have 8x 20 minus 1 equals 19. So when we're writing down our explanation and our justification, we want to find that nice balance of not being too wordy, but also not being too simplistic. And making sure that when we're doing that, we're choosing truly good mathematical words. Okay, we don't want to use words incorrectly. We don't want to avoid using words either just because we don't know what they are. So how can we learn that correct vocab? Okay, so just like we said, our first step was to subtract 1 from each side. So that might be what you write over here, right? We subtract 1 from each side. All right, we're going to tell what it is that we're doing. Okay, so this first piece that we have up here is telling what we're doing. And then our second piece is that we want to describe why we did it, right? That's an explanation and a justification. What you did and how you know that you're allowed to do it. So we subtracted 1 from each side. Well, why did we do that? Okay, we knew with order of operations backwards, we need to undo addition and subtraction first. Okay, and we know the inverse of addition is subtraction. So we're subtracting 1 from each side because reverse order of operations. And yes, this is some writing. Says to move 1 first. And we undo addition with subtraction. Okay, so we're giving a nice, clear justification. Not just kind of, not just I think I know, but here's exactly what I did, and here is why I'm justified in doing it. Okay, and then we'll go back over here and we'll look at our next step. Okay, we're not done solving yet. X isn't by itself. So how do we finish getting X by itself? Well, we need to move that 8. Okay. We undo multiplication with division, so our next step is going to be to divide each side by 8. We know our 8s cancel. Now, yesterday we did a lot of problems that had nice, neat, perfect whole numbers, but that's not always the case. This is totally fine to have a fraction answer. If you want to turn it into a mixed number, you could. If you want to turn it into a decimal, you could, as long as you don't round anything. Okay, I don't care what format your answer is in, as long as you don't round. Okay, so we said we would always start by saying what we did. Okay, so we divided by 8 on both sides. Okay, then we have to decide why we did that. Okay, maybe we're saying because we undo multiplication with division. Maybe I didn't add this piece before. I did say it was to each side, but maybe we add because what we do to one side of the equation, we also have to do to the other. So we divided by 8 on both sides because division is the inverse of multiplication. And whatever we do on one side of the equal sign or on one side of the equation, oops, we have to do on the other. Now, that doesn't mean that everybody's sentence will look exactly like me. Okay, your wording could be different, but again, that key piece that I'm looking for is the first part telling us what you did, and that second part then giving a correct justification for why you did it. So obviously, if your justification is wrong, right? I divided by 8 because that's how I undo addition, right? That wouldn't be correct. So we have another one here. Miles solved this equation. We have his work shown, and we want to describe in complete sentences if Miles is correct or incorrect. Okay, if he's right, we're going to explain why, and if he's incorrect, we're going to explain why not. So my suggestion is sort of always whenever we're given an equation and we want to decide if something is right or wrong, that maybe we want to show our own steps and compare. Which is why I had you kind of put yours over here. You could try and squeeze it in, or maybe you could use some of your extra space of your paper over here, okay? But let's do our own work to compare. So what I'm writing right here is we can do our own work to compare, and then that's exactly what I'm gonna do. I'm just gonna ignore the fact that I see any of Miles' work, and I'm just going to start with that same equation. Negative 3x plus 8 equals 11. Okay, and I'm going to pretend that I don't see anything on this other page, and I'm just going to go through and solve this how I would want to solve this. Okay, so if we do order of operations backwards, we know we're undoing addition and subtraction first. So I'm going to subtract 8 from each side. And then I'm going to undo that multiplication with division. Okay, once I have my work, now I can compare to Miles' work. Okay, well, the first thing that I did was subtract 8. The first thing that Miles did was add 8. Well, I know if I want to undo addition, I need to use subtraction. So I definitely need to make a note that right here, Miles made an error. So we know he's not right. Okay, well then the next thing I did was divide by negative 3. And that does look like the next thing that Miles did. So it looks like right here what we just need to explain is he made an error with his inverse operation of addition. Okay, so just like we did before, right? We're always going to have this basic starting point where we answer the question. Okay, up here our question was, well, you know, what did we do? Okay, what we did. Down here, right, we're going to sort of start at what he did. And in this case, what he did wrong. If it was right, we'd explain what he did right. Now we want to explain what he did wrong. So what did he do wrong? Right, Miles is incorrect. Because... Okay, and then what did he do incorrect? Well, Miles should have used subtraction instead of addition. Okay, so Miles is wrong because he didn't use the inverse operation. Right? His first step should have been, now I probably should have been more clear up here, but if we're ever saying that it's wrong, a good way to justify that something is wrong, if we want to justify that something is wrong, is to tell what it should have been if it was right. Okay, so if we really want to justify why it's wrong, we are going to show what's right. And maybe a better word than prove is maybe to justify or to explain, but right, if we're trying to show that something is wrong, we could show that by telling about what is right. So what he should have done subtracted 8. Okay, so we're giving a good explanation, we're telling if he's right or wrong, but we're also being clear on what that correct work should have been as well.